In this tutorial, we will be discussing how to do conversions. They're also called dimensional analysis. Okay, oftentimes in chemistry, you have to do conversions of some kind. Grams to moles, meters to millimeters, so on and so forth. So this requires you to change the units and the numbers that represent them. So when you're doing these, there's several things you have to remember. You have to figure out what the given quantity units are, and that you'll get that from the question itself, and what units you're actually needing, which will also be in the question. And then the conversion factors that you need to connect those two. Now those will either be in the problem, or it's very possible that you have to memorize them. If they're prefixes like milli, centi, kilo, those should all be memorized. Alright, so rather than trying to take you step by step without doing any kind of examples, I'm going to jump right into it and just talk my way through it and go rather slow so that way you can see where I'm putting what number and why. So if a person weighs 164 pounds, what's the body mass in kilograms? So 164 pounds, that's our starting number. That's what we're actually trying to convert. That's going to be our initial unit. The kilograms is the unit that we're looking for. So to go through this process, the first thing you're going to want to do is take that starting number and put it over 1. So 164 pounds goes over 1. Now, in previous tutorials, I've talked about taking equalities and converting them into conversion factors. And I said not to get caught up on creating the fraction right away, but rather let the question guide you as to where to put which numbers. So this is what I'm talking about right here. Here's our conversion factor for pounds to kilograms. 1 kilogram is equal to 2.20 pounds. So I have pounds on the top. That's what I want to put on the bottom of the next one, bottom of the next line. If I look here, there's 2.20 pounds in 1 kilogram. That 2.20 is right next to the LB for pounds. It's on the same side of the equal sign, so those two things have to stay together. Similarly, here's the equal sign. The 1 and the kilogram have to stay together because they're on the other side of the line. Now there's a couple different ways that you can do this. I'm going to spell it out all the way the very first time, and then I'm going to take shortcuts. So basically what you're doing is you're multiplying fractions here. So you're going to multiply the top, and then you're going to multiply the bottom. So we have 164 pounds times 1 kilogram divided by 1 times 2.20 pounds. Alright, so let's get rid of the letters first. So we have pounds here and pounds here. Those cancel out. Just like 5 divided by 5 cancel out, pounds divided by pounds cancel out. That leaves us with kg at the very end. Now let's look at the numbers. We have 164 times 1 divided by 1 divided by 2.20. That comes out to be, if you put that in the calculator, 74.5454. Alright, so that's how you do an actual conversion and you set it up. Now the very, very last step is to look at the significant figures. These here, the conversion factor does not count when you're looking at significant figures. What you want to look at is that first starting number. So 164. There's 3 sig figs in there. That means we're going to have 3 in the answer. So it comes down to 74.5 kilograms. Alright, let's try another one. A rattlesnake is 2.44 meters long. That's going to be our starting number again. Then how many centimeters long is the snake? So 100 centimeters is equal to 1 meter. Because that's the prefix, you're going to have to memorize that. So 2.44 meters is our starting point, so that goes over 1. We have meters on top. We want to have meters on bottom. Notice the number 1 is on the same side of the equal sign as the M. So those two things go together. That's equal, which means that's the line, to 100 centimeters. So I'm going to shortcut it now. I'm not going to write it all out. The meters cancel. We're left over with centimeters. If the number's on top, you multiply it. If the number's on the bottom, you divide. So 2.44 divided by 1 times 100 divided by 1. That comes out to be 244 centimeters. There's 3 significant figures in that first number. There's 3 in the answer. All right, oftentimes you're going to have a situation where you have more than just one conversion factor that's needed. So we'll do a couple of those practice problems as well. Okay, this one's a fairly complicated one. It's specifically for medicine. A doctor says that a patient needs 0.150 milligrams of Synthroid. However, the tablets that you have are 75, remember that's micrograms. So we have 2 situations. First of all, the doctor's giving you the prescription in milli. The tablet's giving it to you in micro. The other issue we have going on here is you're not going to give them straight Synthroid. You're going to give them a tablet that contains Synthroid in it. So you need to figure out how many tablets you're supposed to give them. Okay, so putting that all into perspective, we have a couple different conversion factors here. First of all, let's get milli into micro. I personally like to go through the base unit just because that leaves less confusion in trying to work things out in my head. So 1,000 milligrams is equal to 1 gram, and 1 million micrograms is equal to 1 gram. Okay, so now we can get from milli to micro. Now the next thing we need to do is figure out how many tablets to get. So for every 1 tablet, there are 75 micrograms. Alright, so let's figure out how many tablets we should give this patient. The doctor says 0.150 milligrams. That's going to be your starting point. You might be asking, how do you know which number to use? You see 2 different numbers here. How do I know to use 150 and not 75? The answer is that 75 was used as part of a conversion factor. And because of that, it can't possibly be the first number. So that's why I'm going with the 0.150. So 1,000 milligrams is 1 gram. Now let's convert it over to micro, and 1 gram, there's 1 million micrograms. Now that we have it in micrograms, which is what the tablets are consisting of, we can use the tablet information. For every 75 micrograms, there's 1 tablet. So now we can cancel out the units we don't need. Milli gets canceled, grams get canceled, micrograms get canceled. That leaves us with tablets. Believe it or not, all these numbers come down to 2. 0.150 divided by 1,000 times 1,000,000 divided by 75 is 2. Now, if you'd like, you can put this 2.00 since there's 3 significant figures here. However, because we're talking about tablets and we're counting, it could be considered that those are infinite, so you don't necessarily need significant figures with those. All right, so let's take a little bit easier one. 1.4 days. We're trying to figure out how many minutes there are. In 1 day, there's 24 hours. And then 1 hour, there's 60 minutes. So 1.4 days is going to be our starting quantity. So 1.4 days over 1. Days are on top, so I want to put days on the bottom. And each day, that equals 24 hours. the days cancel. That should be a time sign. So now we have hours on top, which means I want to put hours on the bottom. Here's hours. For every 1 hour, that equals 60 minutes. So 1.4 times 24 times 60, 2016 minutes. Now, there should be two significant figures here, which mean I want the 2 and the 0. The only way to make this the correct significant figure is if I put 2.0 times 10 to the third. Because if I just put 2,000, then those zeros don't count. One other thing I would suggest is that as you are using this, the conversion factors, cross them out so that way you don't get confused by them again. And this will be our last practice with these. Okay, so you're on the treadmill, you're going 65 meters per minute. That's our conversion factor. How many minutes will it take for 7.5 kilometers? So you're given it in meters per minute, but the question is asking about kilometers. So 1,000 meters is equal to 1 kilometer. So there's our conversion factors to get us to minutes. 7.5 is our starting number, so that's going to go over 1 to turn into a fraction. We have kilometers on the top. Put kilometers on the bottom. That is equal to 1,000 meters. So that gives us to the meters part. Now we can cross out kilometers. I'm also going to cross this out so I don't get confused by it. And we're going to convert it over to minutes. There are 65 meters in every 1 minute. The meters cancel, and we're left over with minutes. When we put this in the calculator, 7.5 times 1,000 divided by 65. 115.38 minutes. You round that off to 120 minutes because our starting number only has two significant figures. And that's how you do conversions.